Okay, so this video is about parallel and perpendicular lines, right? So before we go through this, let's go through how we figure out parallel lines. So parallel means that they have the same slope, right? So if I look at this problem, y equals 7x plus 3, 7 is my slope, so that means the parallel line will have the exact same slope, okay? In y equals 12 minus 2 over 3x, my slope is negative 2 over 3, and that would be the same in my parallel line. In y equals 6 plus 3x, my slope this time is a plus 3, which means my slope for my parallel line will also be a positive 3. Okay, so that's the big thing, is slopes don't change in parallel. So let's go through our parallel equation foldable. I'm going to pull this to the side here. Now, we have this parallel to y equals 5x plus 1. Well, first things I'm going to do is I'm going to graph y equals 5x plus 1. Now this 1 is my y-intercept, so here's my origin, here's my y-intercept. And then this slope tells me to go up and right, so I go up 5. Oh, I can't go up 5, right 1. So instead I'm going to go down 5, left 1. And this is the most points I can currently draw, so I'm going to draw a straight line through it. Now, what I'm going to do is I'm going to figure out my other equation. Now, my slope in this one, we're going to make this equation red, is 5. So my slope for my parallel line will also be 5. So when I write this out, the slope isn't going to change. It's still going to be y equals 5x. I know that. What I don't know is my y-intercept. And what I can do is I can use the information I'm given. Now, I know the equation of the first one, and I also know the point, right? So what I can do is plug that information into y equals mx plus b. Now, again, I know my m is 5, so I'm going to replace this m with the number 5. This point 2 is my x value. So I'm going to put that 2 with my x value, but I don't write it as 52, right? Because there's secret multiplication happening between m and x. So I'm going to put it as times 2. And then I also know this 5 as my point is a y. So I'm going to say this is 5. Everything else, we drop it down. And then from here, we use our solve skills. Okay? Now using my solve skills, now I know y equals 5x minus 5. Now this minus 5 is my y-intercept, so I'm going to graph it. Same slope, so I'm going to go up and right. So up 5, right 1, up 5, right 1. And look at that, it's parallel. Just like when we talked about in systems, parallel means they're never going to touch. So if your lines look like they're about to cross, you made a boo-boo. Let's look at another example. So I'm going to go ahead and graph the original equation they gave us. So this is my y-intercept of negative 2, start at negative 2. My slope is 1 over 1, so I go up 1, right 1, all the way through it. All right, now, once again, we're doing parallel lines, so that means my second equation will have the same slope. So I still know that this is a 1. I know that this is a 1. I also know that this is a 1. That's a lot of 1s. Now, I know my x is this 2 right here because they gave me a point x because it's going through that point. The parallel line is going through that point. So I'm going to do times 2. And then my other friend here is my y. So I'm going to put that with my y. Everything else doesn't change. So I'm going to drop it down. And now I'm going to solve for b so I can figure out my parallel lines y-intercept. So let's go do that. So my other b is plus 0. Now we don't write plus 0, like that looks kind of silly, but for this case we will. So I start at the origin, or our y-intercept is 0. And I go up 1, right 1, all the way through. And look at that, I got parallel lines once again. Are my lines the straightest? No, but they're still parallel. I want you guys to try this one on your own. Okay, in this one, I graphed the original equation. Here it is. My slope is 3 over 5. That's not going to change. And then my x was 5. My y was 5. I did some solving skills, and that gave me my y-intercept of 2. So when I graphed it, I started 2, and then I go up 3, right 5, down 3, left 5 to go in the other direction. Very good. All right, so that's parallel. Now let's talk about perpendicular. So perpendicular, before we get started on that, let's figure out how to solve for perpendicular. So perpendicular, if I know my slope is 7, a perpendicular slope, we flip around and change the sign. So a perpendicular slope to 7 would be -1/7. I flipped it around, so it's on a different part of the fraction, and then I changed the sign. So let's do that again. Now in this case, my slope is -2/3. So I'm gonna flip my numbers, locations on the fraction, and change the sign. So it'll be a +3/2 for the perpendicular slope. And then let's look at this one. We have y = 6 - 3x. So my slope is -3. I'm going to flip that around on the fraction and change the sign. So it becomes a +1/3. Okay, so that's how you figure out what a perpendicular slope is from the original slope. Now let's do some problems together. So once again, I'm gonna just graph this equation really quick just to show you what perpendicular kind of looks like. So our equation started at the y-intercept 1 up to right 1. Now, in this problem, to figure out our slope though, our original slope was 2. So the perpendicular slope, we flip it around and change the sign. So we got -1/2. So my second equation is gonna be -1/2x. And I'm gonna keep that negative sign with the top because I always tell you guys to write it how you say it. And then just like before, we know how to do the rest of this because we know that this is the x value and this is the y value. We know our new slope is -1/2. And don't forget these are being multiplied. So go ahead, and from here, I want you to solve for b. So from here, we get our y-intercept of 5. So this is a +5. I start up here. This tells me to go down and right. So I'm going to do down 1, right 2, down 1, right 2. And here, let me draw my line straight, is my perpendicular line. Now when it's perpendicular, okay, if I look at this, it kind of makes a 90-degree angle, or it kind of makes it look like perfectly crosses, like how these x-axis and y-axis, they're always perpendicular to each other. So that's what perpendicular means, is it makes like this perfect crossing where you can draw beautiful squares from there. Okay, so that's what perpendicular means. All right, let's look at the inside. So what I'm gonna do is I'm gonna graph the original equation here first. Start at y-intercept of -2, you go up 5, right 3. So that's what I did. Now my original slope is 5/3. And so when I do the perpendicular, I want to flip around the fraction and change the sign. So this becomes a -3/5. So I already know that my new equation is going to start with -3/5x. And now I want you to go ahead and solve from here without my help. All right, so my y was 2, -3/5 was my m, my x value was -5. Solve for it and you get -1. So my new equation is y = -3/5x minus 1. So that starts graphing right here. This tells me to go down and right, so down 3, right 5, and then up 3 and left 5 to go in the other direction. And when I draw my line here, it does kind of make that square shape when they cross. So that means it would be perpendicular. I mean, this isn't perfect, but you know, freehand, I did pretty good. All right, this last one, I want you to find the other equation totally on your own. Go for gold. -1/2, if I flip it around, it becomes a 2 and it becomes positive because we were talking about perpendicular, so we flip and change the sign. You could write it as, you know, 2/1, like this, that's fine, but it just makes you look silly. And then when I plug in all the stuff that I know, my b becomes -4, so my full equation is y = 2x minus 4. But when we graph it, we want to know that we're going up to right 1, and here it is graphed, everything graphed, and it does kind of make that perfect little box thing when I graph it, so I know I did good. All right, this was the end of the video. I hope you enjoyed it.